This lesson is going to cover the basics of geometric sequences, and then later on we're going to revisit the concept of a geometric sequence and then extend it to geometric series as well. So we have some learning targets for geometric sequences, and this is probably new to most of you. So the not very formal definition of a geometric sequence is that the terms have the same common ratio between them, which I know the word ratio to us typically means division or fraction, but multiplication is division, so we have to keep that in mind. So the terms have a common ratio is what I'm going to jot down. And then that common ratio is basically what you're going to multiply by. So you have the first term, and you're going to multiply by some common ratio, and then it'll give you the second term. And then continues on and on and on. So it's going to be pretty easy for us to come up with formulas for these. The explicit and recursive are pretty basic. So the explicit formula for a geometric sequence starts off a sub n for all sequences, and then we're going to use the formula a sub 1 times r to the n minus 1 power. So first term, of course, is a sub 1. And then r is this new common ratio thing. So how you find the common ratio depends on the complexity of the problem. A really easy way to find the common ratio is just to take the second term and divide it by the first term. Or this could work for any two terms in the sequence that are next to each other. So like it could be the fifth term divided by the fourth term, or the 10th term divided by the 9th term. You're just trying to figure out what to multiply by to move forward in the sequence, so that way if you want to work backwards, you're going to have to divide them. That's it. So a recursive formula for a geometric sequence starts off as a sub n, and then it's actually really quite boring. It says a sub n minus 1, so the previous term, and then you're going to multiply it by this common ratio. And then, of course, they have to give you a starting term. So when I look at these sequences, I have to determine if they're geometric or not. So geometric is going to have a common ratio that you multiply by every time. So if you could think about how to jump from here to here, that would be multiplying by a negative 1/2. But if you didn't see that, you could take 8 and divide it by negative 16 and get the negative 1/2. Now you have to determine if that's the case every time. So if you keep multiplying by negative 1/2, does it keep working? So 8 times negative 1/2 is negative 4. Negative 4 times negative 1/2 is positive 2. So yes, this is geometric, which means our common ratio is that negative 1/2 that we saw. Now this one, to go from here to here, looks like they're multiplying by half, because 10 divided by 20 is half. But that is not the case to go from here to here, because this cut in half would be negative 5. So no, not geometric, which means I don't have to do any work on it. Alright, they do that thing with the fractions that I don't like. So if we could figure out the pattern here, I could rewrite it maybe as a fraction, but let's just find the common ratio. Let's see if that works. So taking the second term, 4/3, and dividing it by 2, which we know dividing by 2 is multiplying by 1/2. According to this, the common ratio would be 2/3. So let's see if that works. So I already know this one works, multiply by 2/3. If I multiply 4/3 by 2/3, I get 8/9, yep. And if I multiply 8/9 times 2/3, I get 16/27, yep. So yes, this is geometric, and the common ratio is 2/3. Alright, let's check out 7. Oh, read the directions, Abruzzo. Find the common ratio. They already told me it was that. So silly. I didn't have to do all that work. My bad. And then find the next 3 terms of the sequence. So we're just going to keep multiplying the next term by 2/3. So let's see, the next term would be, oh boy. Oh no, they just want the next term. Gosh, what am I reading? I think the directions are a little different on your paper, or maybe not. Maybe not. Alright, 16 over 27 times 2/3 is 32 over 81. And then apparently I didn't read the directions when I made my key, so keep going. 32 over 81 times 2/3. 64 over 243. You know, there is a definite pattern here. The problem is my powers are going to get kind of large. Like this is 3 to some power, and this is 2 to some power. So, what's that, 128 to, oh boy, I don't know. 729, totally. Alright, so there's the next three terms. Sorry about that. I can read. Alright, the next one. Apparently it's geometric. So we have the common ratio, which I'm just going to take the second term and divide it by the first term. So it looks like the common ratio is negative 4. So the next term, if I multiply this by negative 4, it would be negative 256. And again, I didn't read my directions, so negative 256 times negative 4 is 1024. And then times another negative 4 is negative 4096. So, first task, can you find the common ratio and can you use it to extend the sequence? Sure can. Moving on. Alright, so I'm giving you an explicit formula. And remember what this means. This is going to be our first term. And then the common ratio is this number here. So R is 6. And, okay. So R is 6, found that part. The first term is 2. And then if I keep multiplying by the common ratio of 6, I'm going to get my next terms. So 2 times 6 is 12. It's 12 times 6 is 72. 72 times 6, I already found it, is 432. So here's the first 4 terms of the sequence. And again, you can define them or you can list them. So you can say like this is a sub 1, and you can say this is a sub 2. You can say this is a sub 3, and this is a sub 4. The notation, I think, is what troubles kids the most at the beginning of this lesson. Okay, first term of our sequence is negative 0.25, or negative 1/4. And our common ratio is negative 4. So if I start applying that, so my first term, clearly negative 1/4. And then if I multiply by negative 4, that gives me a positive 1. If I multiply by negative 4 again, I get negative 4. If I multiply by negative 4 again, I get positive 16. So here's my first 4 terms of the sequence. Alright, so now they are going to give me a recursive geometric sequence, and I have to find the common ratio and then find the first 4 terms. I'm sure that said. There we go. So common ratio is very clear in the recursive formula, as is the first term. So the common ratio is 1/6, and we're going to start the sequence with 108. So the first term is 108, and then if I multiply by 1/6, I get 18. If I multiply by 1/6 again, I get 3. And I multiply by 1/6 again, and I get 1/2. And they want the first 4 terms. And the common ratio. I really like recursive for these. I think they're easier, but whatever. They're all, let's be honest, this is a pretty easy concept. As far as the formula goes, it's not terrible. So here, they don't tell me anything other than a pattern. And I have to find the common ratio and then the 8th term. So the common ratio can be found by just thinking real hard, or you can do 8 divided by negative 2. So the common ratio is negative 4. Now you could continue on until the 8th term, that would work. Or you could go ahead and write yourself a nice quick formula and then plug in 8 for the nth term. So there's no problem with you extending this out to 8 terms. It's not going to be that difficult, but I'm just going to write my formula real quick. My explicit formula. So the first term was negative 2. Our common ratio is a negative 4 to the n minus 1 power. So if I want the 8th term, I'm going to plug in an 8 right there. So I'm going to type negative 2 times negative 4 to the 8 minus 1, or the 7th power. So when I typed that on my calculator, I got 32768. I just know from experience that if I have a formula, I'm less likely to make a mistake. If I have to extend a pattern out for multiple terms, I don't know why, I just can't type right. I can't read either, so what am I going to do? Alright, number 12, on the back of our notes now. Here they do want the explicit formula. So this is going to be part of our formula. That's the first term. And then the other thing I need is R. So 10 divided by 2 is 5. I think we're ready to rock and roll, guys. This part of this lesson is super easy. So 2 times 5 to the n minus 1 power. You can put 5 in parentheses. Just make sure you understand that 5 is the base of the n minus 1 power. So here for number 13, I got a first term. And then common ratio would be 1 divided by 3, or 1/3. So our explicit formula is 3 times 1/3 to the n minus 1 power. I know, this is that moment where you're like, okay, it's going to get so bad. She's going to do that thing where it gets really bad and she doesn't tell me. Not really. Alright, so this one is recursive, and they want me to figure out the explicit. I know that sounds crazy, but all you need for an explicit formula is the first term and the common ratio. So actually, these are probably the easiest ones. So the first term we said was 16. The common ratio was 1/2 to the n minus 1 power. Ta-da! All right, and then 15, first term, common ratio. So our explicit formula is 2 times -5 to the n minus 1 power. Right. You may have been asking yourself why the n minus 1 power? Well, if your first term is when n equals 1, if you plug in a 1 right here, you get to the 0th power, which doesn't multiply by any of the common ratios because it's ratio to the 0 power, so it's just multiplied by a 1. So that's why it's not affected by the common ratio, and that's why the power has to be n minus 1. There are going to be moments in our near future where we define our sequence a little differently, and we start with n equals 0 instead of n equals 1, and that's a different story. Alright, so this is fun. Now we've got to go find the recursive formula. So the recursive formula says it's always going to be the previous term, so a sub n minus 1, times the common ratio, which clearly is a 3. But you have to tell me who the first term is. So the first term starts off with a 3. I know, you're wondering when it gets bad, huh? There's a little bit of trickiness coming up, but nothing terrible. Alright, so previous term times the common ratio, so -6 divided by 3 is -2. Oh, hello. Oh yeah, we're good. I thought I was missing a part of the formula, but I'm not. -2. Okay. I am, however, writing something really silly on my notes. Let me fix this. One moment. I gotta fix my work. Oh no, I'm good. I was looking at the wrong section. Thought I had the totally wrong answer. Okay. Anyways, first term. 3. So I really like those questions. I think recursive, as weird as it is, I think they're really, really cool in the geometric sequence. So here I flat out give you an explicit, go back and find recursive. Remember, that's important, right? That's the first term. This is important. This is your common ratio. I think we got this. So recursive formula will be the previous term times our common ratio. You can put parentheses around that if you want. But your first term is 0.4. Okay, good to go. Here we go. Previous term times the common ratio is the recursive sequence, and we need to start off our sequence with the number 4. Alright, this I think is where it starts to get a little weird. Not terrible though. It does say find the explicit formula, so let's go ahead and do that. And when you're projecting out into the sequence, you really do want the explicit formula. It's the only way to project out easily. So the first term is 3/2. The common ratio, however, let's see, it'd be 3/4 divided by 3/2, so I'm going to multiply it by 2/3, and I'm going to get 1/2 for my common ratio. And then remember, this is the explicit formula, so it's the first term times r to the n minus 1 power. So now when it says find the 11th term, it's going to be no problem at all. I'm just going to plug in 11. So 3/2 times 1/2 to the 11 minus 1 power, or if you just want to write 10 there, that's fine. But if you make this a 10, I think I already did this on my calculator. It turns out the 11th term is, if I hit math on runner, bring it back to a fraction, it's 3 over 2048. Lovely. All right. Same stuff. Common ratio I'm going to find, but my first term I see is -1.5. So common ratio is 3 divided by -1.5, which is -2, right? To the n minus 1 power. So projecting out to the 11th term. Let's see here, -2 to the 11 minus 1, which would be 1536. In that case, you want to make sure that the 10th power is only on the -2. I know sometimes you guys just kind of watch me type stuff and figure that you know how to do it. You might want to practice those a little bit. Alright, so here, this is where it gets this is probably the most exciting part of the notes. So I give you the first term, that's helpful, and then I give you some other random term, which is not adjacent to that term. So finding the common ratio can be a little complicated. So we have the first term, a sub 1, and then I don't know the second term, and I don't know the third term, but I can tell you the fourth term. And this is definitely not the only way to get this question right. I'm just trying to help you visualize a little bit, because the other way is to like manipulate through the formula, which totally works. I just don't know how important it is that you do that. So think of it this way, guys. You multiplied 1, 2, 3 times to get to this next term. So we used to call them steps in the arithmetic sequence, and we can keep calling them steps if you'd like, but this is 3 multipliers, or 3 steps, if you want to keep calling it that way, to get to 24. So think of it this way. You took some ratio, so 3, and then you multiplied some ratio 3 times, 1, 2, 3 steps, because you started with 3, multiplied 3 times, and it got you 24. So solve that for me. So divide by 3, and you get r to the third equals 8. So I know you're worried about radical rules, and do I need a plus or minus? Don't worry about that right now, guys. It's a cube root, so it's just 2. The common ratio is 2. And if you don't believe me, test it out. If you multiply by 2, you'd get a 6, and you multiply by 2, you'd get a 12, and you multiply by 2, you get a 24. So trust in the formula, right? So figure out how many steps you went through, and then set up a little equation. It is going to involve radicals, but you'll be all right. So common ratio is 2. Now I'm going to write my explicit formula. And then I'm going to find the 11th term. So the 11th term is 3 times 2 to the 11 minus 1 power, or the 10th power, which ends up being 3,072. These are the kind of questions that standardized testing used to use a lot, because they were hoping some poor kid would sit there and tinker with the question for 20 minutes and like waste their life. They don't really put them on anymore in the SAT, but once in a while. Alright, 12th term. And this time, I have the second term. That's curious. I don't have the first term. We'll have to come back to that. Alright, we got third term, don't know. Fourth term, don't know. Fifth term, know that. So here's what I know. The second term is negative 4/3. And then the fifth term is 4/81. So I went 1, 2, 3 steps, or 3 multipliers, to get to this term, starting here. So starting at negative 4/3, I multiplied this common ratio 3 times again, and got 4/81. Or, yeah, 4/81. So let's solve that. I'm going to multiply by negative 3/4. Maybe. So these are gone. I have r to the third power equals, oh boy, negative 1/27. And then if I cube root that, it is negative. So my common ratio is negative 1/3. Again, if you don't believe me, test it out. If you multiply this by negative 1/3, oh boy, let's see, you get positive 4/9. If you multiply this by negative 1/3, you get negative 4/27. And if you multiply that by negative 1/3, you get positive 4/81. Notice it's toggling between positive and negative. We're going to learn what that's called later. Now, remember, they didn't give me the first term, so I got to think backwards. Instead of multiplying by negative 1/3, we have to divide by negative 1/3. So in essence, we have to multiply by the reciprocal of negative 3. So doesn't that mean we started with a 4? Because negative 4/3 divided by negative 1/3 is multiplied by negative 3/1. Which makes sense, because if you keep going forward by multiplying by negative 1/3. I don't really like to worry about formulas so much when I'm filling in these patterns. I just kind of visualize it, but do what you need to do, guys. Alright, our first term, our nth term, is defined as the first term, which is 4, times the common ratio, negative 1/3, to the n minus 1 power. So, filling in for the 12th term this time. So that's really the 11th power, and I think I already, oh boy, this is very tiny. It's like scientific notation on your calculator, and so it's not going to allow you to have anything prettier than that. So you can write 7.195 times 10 to the negative 16, very tiny number. Or, if you think about multiplying the 11th power to this fraction, This is like 1 over 3 to the 11th power times 4. So I could write that as 4 over 3 to the 11th power. It's a weird answer. But that would be the exact answer, that's for sure. Alright, so I think we'll... Oh, we have one more to do, and I haven't done it yet on my key. Whoopsies. Alright, let's figure it out. So this time I do have the first term. That's nice. Okay, apparently 3 is our magic number because I'm going to go out 3 steps and find the fourth term. It's not always going to be 3 steps, guys. This worksheet really liked 3 steps, apparently. 1.5 is the starting. This guy is a 12. And I went 1, 2, 3 steps. So I started with a 1.5, and then I multiplied this common ratio 3 times, and I got a 12. So, dividing by 1.5, gosh, I know I totally should be able to do that. 2/3, 4, is it 8? I'm just checking. Yeah, it's 8. So we have r to the 3rd power equals 8, and then cube rooting both sides. Find out our common ratio is 2. So, multiplying by 2 gives you a 3, multiplying by 2 gives you a 6, multiplying by 2 gives you a 12. Alright, we rocked it. Explicit formula. First term, 1.5. Common ratio I just found is a 2 to the n minus 1 power. So if you want the 11th term, 1.5 times 2 to the 11 minus 1 power, or the 10th power. And I do that, so let me find it out. 1.5 times 2 to the 10th power is 1536. I feel like we had that answer before. Oh well, life happens. Alright, there's geometric sequences. So our next lesson is going to bring back arithmetic sequences and also talk about series, and we're going to do a lot of calculator work on the next lesson. So you're going to love that one.